All right, so in 7.2, we're going to be solving exponential equations and inequalities. We're going to do this without a calculator, and we won't need one, so. Okay, so an exponential equation is an equation that contains one or more expressions that have a variable as an exponent. Okay, you have to have your variable as the exponent. And if that happens, then we can use this property, but we can only use this property if the base is greater than 0, okay, and the base cannot equal 1. Remember the other day we talked about if the base was 1, no matter what you did, you would get 1. Okay, so that's why that's going to be an exception. All right, so if that happens, then you can write b to the x equals b to the y as the following. We're going to do a double-sided arrow. You may remember that from geometry. It's the if and only if. Remember when you had to write conditional statements?
Yes.
P if and only if Q. If P, then Q. If Q, then P. If not P, then not Q. You really don't know what I'm talking about?
I just don't want to.
Okay. Remember there's the conditional statement, then the inverse, the converse, the contrapositive.
I just don't like vocabulary.
Okay.
Okay.
So, this is actually something that's really simple. This is saying if you have the same base, okay, if you have 2 to some power of x and it's equal to 2 to some power of y, what has to be true about x and y? Yeah, they're the same. They're equal. Exactly. Look how smart we are. That is exactly right. Because if the base is the same, the exponents have to be the same. Okay, so thus, look how smart we are with those transitions. Thus, we want to rewrite the equations with the same base whenever possible. According to the property above, if the bases are equal, then we know that exponents must also be equal. So, when we are solving each equation, our goal is going to be to rewrite these with the same base. Can we do that for part A? Okay, so we have 9 and we have 27. Okay, I want you to write down the base that each one of those can be written with. Oh, all right. So 9 and 27. Ryan, what do you think? What can I, instead of 9, how can I rewrite that with a different base? Yeah, okay, so, sorry, I'm laughing because he said trace. So 9, you can rewrite as 3 to the power of what? No, 27 would be. But this one would be 3 to the power of? Yes, great. Okay, so 9 you can rewrite as 3 squared. And 27 you can rewrite as 3 cubed. Close the parentheses too soon. So when you do that, please notice that you are not changing the value of the base. 3 squared is still 9. 3 cubed is still 27. And so we are still going to keep the exponent, 8 minus x, and x minus 3, just as we had before. And now we're going to apply a property of exponents. Okay? So if you have a power to a power, you might remember that when you have a power to a power, you have to do what? Multiply. Yep. Okay, so we are going to, in this case, we're going to have to distribute. Once you rewrite them with the same base, you can decide if you want to distribute at this step or the next step. I'll show you different ways, and then you guys can pick your favorite, choose your own adventure. So when we do this, 2 times 8 is 16, 2 times negative x is negative 2x. Okay, and then here, we're going to distribute to get 3x minus 9. And now we can use the rule that we just talked about above. If the bases are equal, we're only going to write this down for the first one, and then we'll just apply it. So if the bases are equal, the exponents are equal. If the bases are equal, the exponents are equal. When I say the bases are equal, you say the exponents are equal. Are we ready? If the bases are equal, the exponents are equal. Nailed it, except for this back table. Oh. So let's try one more time for the people in the back. If the bases are equal, the exponents are equal. All right. Okay, so let's set those exponents equal. Okay, so like we said earlier, if they have the same base and we know that they're equal, these exponents, they have to be equal. Now we just have a nice algebra 1 equation. Yay. Okay, so I'm going to move my x's to one side. Whichever side you would like to move them to is fine. I like to move them to the side that's going to keep them positive. I'm sure many of you are the same. Okay, now, do you guys think we have to check for extraneous solutions here? The correct answer is no, not because we don't want to, but why, why do we not have to check for extraneous solutions? Well, I am right most of the time, so, but that's, mathematically sound answer. How do we know there's not going to be any extraneous solutions here? Okay, so there's no restriction, there's no square root, there's no, right, that would go with the square root, there's no fractions, right? And that all ties back to the domain. Remember the past 2 days when you were graphing? Every time you had to write the domain, what was the domain? All real numbers. If the domain's all real numbers, you don't have to worry about extraneous solutions. Okay? All right, now, when you have one like B, sometimes we can trick ourselves into thinking, oh yeah, 4 times 8, that's 32, right? But is 4 to the 8th power 32? No, that would be 4 times 4 times 4 times 4, 8 times, right? So we can't rewrite 32 with 4, but we can rewrite 4 and 32 as a power of what? 2. All right. So I want you guys to try that. So I want you to try to rewrite each side with a power of 2. Okay, I'll come around in case you need some help getting started with that. And I will tell you for part B, if your answer is a fraction, we're doing something right.
Right.
We're doing something right. If it is a fraction. Okay, so Titan, tell me how you rewrote 4. Good. Okay, so base of 2, 2 squared, and then how'd you rewrite 32? 2 to the 5th. Great. Now, on this side, you do have to distribute. You can distribute in this step, or if you want to just write out, like now that you have the base of 2, if you want to write out the exponents are equal here, exponents are equal, now that the bases are the same, you could do that. Okay, you could even just jump to this step when you guys are working, that's fine. 10x plus 2 equals 5. Okay, so then you're going to subtract 2 from both sides, divide by 10, x is going to be 3/10. Okay, so remember, when you are doing this, you need to make sure that your base is greater than 0 and not equal to 1. So you have 2 and 1 over 32. We just wrote 32 with a base of 2, a power of 5. Okay, who wants to tell me how to rewrite that? Yeah, let me get that. 2 to the, it won't be 2 to the power 1/5. Elijah, what do you think? Yeah. So remember, it's the negative that puts the 1 over it? Yeah. Okay, so 2 to the negative 5th power would be 1 over 32. This is already written as the base. So sometimes you don't have to rewrite both of them. Maybe one of them already has that base. And then from there, we can set our exponents equal. Okay, we're going to get all of our numbers on one side. Okay, and then remember, your final answer needs to be reduced. So I want you to reduce part C. Okay, and then I want you to think about what your base is going to be for part D. Okay, so you can work with your row on that. I want you to come up with a base. All right. So your final answer for C should be -3 over 2. All right. And then Ian, what does your row think the base should be for part D? Oh, so then what do you think then? You can't be dividing by 2 for 3 minutes. Okay, so let's look at it together now. Okay, so you have 1/5 and 1/25. So what do you think? What do those have in common? Okay, yeah, so 5 goes into both of them. Okay, so you could rewrite both of them with a base of 5. How would you write 1/5 with a base of 5? Be 5 to what power? You got this. Yeah. Yeah, you got it. Okay, so you do have to make sure that you do 5 to the -1. Okay, I know, were some of you thinking that there's another way that you could do this? You weren't? So 1 over 25 would be 5 to what power? -2. All right, so go ahead and solve that. Okay, and then while you guys are doing that, I'm going to see if this will work with a different base. Because did some of you think, yeah, so then let's see if 1/5 works. your final answer? Good. Okay, so I did the 1/5 on the board. Did we get the same thing? Yes. Okay, so for these, for your equations, okay, some of them might have a different way that you can do it, and that is fine. Okay, so you can do a base of 5, or you could do 1/5 to the 2x. I'm just going to write the first step. And then if you do have something in parentheses, you can put like the brackets or the double parentheses. Okay, and you'd end up with the same thing. Okay. All right. So that is equations. Now we are going to talk about exponents. Okay, and exponents also have some special properties that we need to follow in order to use them. Okay, so the property of inequalities for exponential equations tells us if b is greater than 1, then, and there's going to be two cases. Okay, so the first case is if you have greater than. Okay, so then b to the x is greater than b to the y if and only if. You guys remember you used to write if and only if as IFF? Did you see that?
No.
Did you do it? Write it like this, IFF. Oh, you had to write out the whole thing, if and only if? Oh. At least that's a big difference. That builds character.
Sound like the dad from Calvin and Hobbes.
I sound like the dad?
Did you ever meet Calvin? What? You ever meet Calvin? What do you mean?
Alright, so then if you have greater than, it's going to follow that x is greater than y. If you have less than, it will follow that x is less than y. And these are going to follow the same rules if you have the greater than equal to. Okay, so we're not going to write out the whole thing. So this has the same rules for greater than equal to. This has the same rules for less than equal to. Okay. One thing we have to remember about inequalities is if you multiply or divide by a negative, the sign flips. Okay, so that is something that we will encounter. So you have to make sure that you follow the condition where your base is greater than 1. Okay, so you can't have a negative base there. Okay, your base has to be greater than 1. Okay, so I have 1/36 and I have 6. So for this one, you are going to rewrite each one with a base of what? 6. Yep, so it'll be 6 to the -2 anytime it's a fraction. That one already has the base. Okay, so we have -12x. Negative times a negative is a plus, greater than 3x minus 9. Okay, and I want you to go ahead and solve it from there. Okay, so when we had an equal sign, I just want to point out, when we had an equal sign, we were able to like rewrite this as 1 over 6, but your base has to be greater than 1. Okay, so you're going to have to use values greater than 1. So no fractions that are in between 0 and 1. Okay? All right, and then we are going to write this so that our x is on the left-hand side. So in order to do that, sometimes I will just move everything to the left already, so I have that already set up. Even though that is going to make them negative here. And when you divide by a negative, the sign is going to flip. So this is your final answer. Okay, so when you divide by a negative, you have to flip your sign. Okay, if you did it the other way, okay, if you have negative 12x plus 6 is greater than 3x minus 9, if you add 12, and you get the 15x here, and then you add 9 to get the 15, okay, when you do the last step, you'll just rewrite it with your variable on the left. And I really do still think about like the alligator eats the bigger number, so if it's eating the one this way, it's gotta eat it that way. Okay? Alright, now 64 and 256. Remember, we're doing this without our calculator. Okay, so 64 I know breaks down into 8 and 8. I'm going to do a factor tree for each one. Excuse me, we are going to do a factor tree for each one. I said we. Okay, and this is something that we talked about when we were working with radicals on that historical packet about how you can rewrite things. Okay, so for 64, you have 1, 2, 3, 4, 5, 6 2's. So you can rewrite 64 as 2 to the 6th power. Okay, let's see if we can rewrite 256 as a power of 2. So when you divide by 2, you cut it in half. Divide by 2, cut it in half. And then 64 we know is what? We just did it. It's 2 to the 6. So this is 2 to the 6. Yep. This would be 2 to the 7, 2 to the 8. Okay, so altogether, that would be 2 to the 8. Okay, so 2 to the 8, 2x plus 6. Okay, so you do need to write the step where you have the same base. Okay, this step is essential to have that on your paper. And then if you want to do the distribution in your head, like I said earlier, it's fine if you go straight from this to 24x minus 48 is less than or equal to 8 times 2 is 16, 8 times 6 is 48. Okay, that is fine. Okay, in terms of work, I'm looking for some factor trees with this bigger number, rewriting with the same base, showing that the exponents are equal. Okay, and then we want to get all of the x's on one side. So we have 8x here. What's 48 plus 48? 96. 96 divided by 8. 12. One of our rules. Okay, great. Yes.
You use the basic for it too.
Yeah. Yeah, because you have you could do 4 4 to the third, and then 256 was 4 to the fourth. Yeah. Unusual cycles. Yeah, you have 2 2s there, and then 3 more roots of 2s. Yeah. All right. After you guys get this written down, I will put the book up for you.